All right, so just like we said before, a rectangle, one of the special cases of parallelograms, is a quadrilateral with 4 equal angles. In fact, I'm going to be more specific. Beyond just a quadrilateral is a parallelogram. Of 4 equal angles. 4 equal angles. Not 4 equal sides. That's a different type. 4 equal angles. Now, you guys are probably familiar with the fact of a rectangle having opposite sides be congruent as well. You guys know that if this was 2, this would also be 2. If this was 5 1/2, this would also be 5 1/2. That is not the defining characteristic of a rectangle. It is a property of a rectangle because we know it is a parallelogram. That's why many of you, if I asked you to draw one out, you would know that property. It is by happenstance, because it is a parallelogram, that we have this factor. The definition of a rectangle: a parallelogram that has 4 equal angles. Any questions about a rectangle? We've recorded all the properties already of a parallelogram, so I'm not going to go into that again. All right, so one of our main properties when it comes to rectangles is the fact that a rectangle is a parallelogram. If we have a rectangle, then it must be a parallelogram. Because this is true, all the properties of a parallelogram is also true for a rectangle. Again, we've recorded these already. You can see my video on parallelograms if you forgot what those properties were. There is one additional property. If we know that something is a rectangle, then its diagonals must also be congruent. Before we had diagonals bisecting each other. Now we know that these diagonals not just bisect each other, but they're also congruent to one another. There are many applications to this that we'll see when we start to look at some of these problems. Please record down the properties of a rectangle. Now, one very, very important thing we need to make sure we are aware of. Theorem 641 says all rectangles are parallelograms. That does not mean all parallelograms are rectangles. We cannot apply this property to all parallelograms. This only works for rectangles. Only for rectangles. Only for rectangles. We cannot say that is true for all parallelograms. All right, so what we're going to be looking at is a real-world application of the properties of a rectangle. So what I would like you guys to do is I'd like you to pause the video and see if you can fill in the important information that is given to us in this problem. And let's make sure we annotate the problem as well. All right, guys, let's check it out. Let's annotate. Can someone tell me some important words in this problem? Important words in this problem. Yes, Sabrina? JL equals 86 centimeters. Anything else that is important? Yes, Clea. JK is 50 centimeters. One more thing is very, very important in this problem. What word in this problem is of the utmost importance? Yes, Zainab. Rectangular, which is a word for a rectangle. Now, we could not answer this question without this fact. That's why this is so important. You can't answer the question if you don't know if it's a rectangle. That's why identifying what type of quadrilateral it is going to be probably the most difficult portion of this course. Not always will I tell you it's a rectangle. We know that this is a rectangle. Rectangle. So it has all the properties of a parallelogram and a rectangle. It's going to go off the screen, but you guys get the idea. It is a rectangle and a parallelogram. Yes, Carlos? Yes, you may. Now, let's label in this important information. JK is 50. I've been given that JL, this whole length is 50. This whole length is 50. Now, I'm interested in what is HM. Which length did they give me to help me find the length of HM? Yes. Oh, sorry, it is 86. My apologies. Sorry to my viewers out there. We'll fix that.
You do know your viewers.
It's 86.
Kids in your class.
This length is 86. So which one is more important? JK or JL? JL. Which property am I going to use to find the length of HM? Yes, Clea. We're going to use that property, well, property 4 in a second. What's the length of KM? What does KM equal? Yes, Kayla. It is also 86 because the diagonals are congruent, because it is a rectangle. If it was not a rectangle, we could not say that both of our diagonals were the same. Here I know that KM is the same as JL. They're both going to be 86. Now, I can use what Kayla said earlier, or Clea said earlier. I can use that property 4 of a parallelogram. Because it's a parallelogram, I know that the diagonals are bisected. The diagonals are bisected. Therefore, these two are going to be the same. In fact, all 4 portions of the diagonals are the same. What is the length of HM going to be? Yes, Liz? What is the length of HM going to be? Well, KM is 86. So how can I figure out the length of HM? Yes, Jada? We would divide it by what? And which is? 43. We know that this length has to be 1/2 of 86. Therefore, it's going to be 43. 86 divided by 2. Because this is a parallelogram and a rectangle, we can apply both of the properties here. That's why this problem is so important. All right. Now, in this problem, I've given you a gate here. We're doing a carpentry example. I would not like you to just find HJ. I would like you to find for me also HK and LG. The length that I gave you here, that 30 and 8/10 is the length of JL. Use that as the length of JL. And I will give you bonus points if you can tell me what the length of JK is here. If you can figure out what the length of JK is as well. So pause the video and see what you can get. All right, guys, let's check this out. Now, I'm going to start with HJ. HJ. What length in this problem is going to help us find the length of HJ? Yes, Angela? It's going to be equal to GK because we know opposite sides are congruent. That's a property of a parallelogram, which is very helpful. We know this is true because it is also a rectangle, right? Now, we know that GK is 48, so that means HJ, or excuse me, is also, or sorry, HJ is also 48 inches. Excellent job. Thank you. Now, let's look at HK. What length is going to help me find the length of HK? What length is going to help me find the length of HK? Yes? And why did you multiply 30.8 by 2? Well, yeah, it's half of this diagonal. So we know that this length is also 30.8. So if we know the length of GJ, wow, that's a mouthful, GJ, we know the length of HK. So what is the length of HK? Anybody? Yes, go ahead, Carlos. 61 and 2/10. We know once we figure out this whole length, it's going to be the same because the diagonals are congruent. We know the diagonals are going to be congruent because it's a rectangle. Now let's look at LG. LG. I guess we kind of already figured that out because we had to apply the property of a parallelogram that both these are going to be congruent. Pretty easy follow-up. We know that LG is going to be equal to JK. Again, that's a property of a parallelogram, not even a rectangle. So we know that LG equals 30.8 inches. Excellent job, guys. Now, I'm going to clear all this out so we have a little bit more space to figure out what JK is going to be. Let's clear all this mess out. All right. JK. Does anyone think they know how to find the length of JK? Yes. We would use the Pythagorean theorem. We know JK, being right here, is part of a right triangle. We know that in a rectangle, all of the angles are 90 degrees. We saw that in our first diagram, in the first portion of this video. So, can someone help me fill in our Pythagorean theorem here? Anyone want to help me fill in the Pythagorean theorem? What is the Pythagorean theorem? Yes, Abdel, what is the Pythagorean theorem? Excellent, it's a squared plus b squared equals c squared. Now, does anyone think they can fill this in? Fill this in for me. Anyone want to give it the old college try? College try. What does c have to be in the Pythagorean theorem? It has to be the hypotenuse. Do we know the length of the hypotenuse? What is the length of the hypotenuse? 61.2, right? It's this whole length, 61.2. Do we know one of the legs of this triangle? Do we know one of the legs of this triangle? Yes, we do. What is it? It is 48. 48 squared. And we're trying to figure out what the other is. So I want you guys to pause the video now and figure out what JK is going to be. Oh, sorry guys, I want to make sure we fix this. It is not 62, it's 61 and 6/10. 61 and 6/10. So make sure you fix that in the previous one. 61 and 6/10. Thank you. All right, let's check it out. What is 48 squared? Can someone tell me what 48 squared is? Someone plug it in their calculator. What is 48 squared? 2,304. What is 61 and 6/10 squared? Someone's got to help me out. I cannot do this one in my head. Wish I could. That'd be super impressive. 3,794. And what's the decimal? 0.56 and 56 hundredths. Let's start to move a little bit off there. 56 hundredths. Now, let's solve. Subtract 2,304 from both sides. 2,304. Can someone give me that? A squared equals. That was 1,490. 1,490. And what's our decimal? 0.56. Oh yeah, it should stay the same. So how do I get a by itself? We take the square root of both sides. So we know that a equals the square root of 1,490 and 56 hundredths. So what does a approximately equal? Yes, Kalia? 38. Is there any decimal? 37. Okay, so perfect. It does round up to 38. Perfect. Inches. So we can see the one nice thing about a rectangle is within a rectangle we can use the Pythagorean theorem. All right, so we've looked at some of the properties of a rectangle, which again are similar to the properties of a parallelogram. In fact, all the properties of a parallelogram apply to a rectangle. So make sure when you're looking through these problems, if you see it's a rectangle, like right here, see it's a rectangle, also write down that it is a parallelogram. Thank you. And make sure you check out my next video on special quadrilaterals.